Wind energy is a very popular um, source of renewable energy today. We're finding much new investment in it. I wanted to first, before we get into some of the specifics of the value of wind energy as a renewable resource, kind of introduce you to the idea that windmills, things that convert wind energy to mechanical energy and then um, at the end electrical energy, come in many different forms. So we have the most popular at the industrial level, this idea of a horizontal axis wind turbine. And then we have some that actually can be placed up on top of buildings. So here we have in this photograph here, we have a vertical axis turbine with I think it's a horizontal rotor, but it's in a helical shape. Um, Placed on a green roof, it looks like, and able to generate some sort of electricity for the building. So we have so primarily a horizontal rotor and a horizontal axis wind turbine. Favonius are really not very efficient, but you'll see these in small applications. And the Darius, this kind of looped one, is also another small application wind turbine. Um, but you don't see many of these except in small applications of wind support power, of which I have a couple of illustrations of. So here's another vertical axis wind turbine in a roof application generating electricity. The um, the amount of power coming off of these compared to the amount of power requirements of the buildings is in the order of small percentages. Um, they're done to kind of send a message to the viewer that the building is concerned about environmental energy usage. But I really, in all honesty, I feel it's a little suspect on whether these are providing enough energy for the building to warrant what are really complicated structural issues with placing these things up on rooftop. So if you're going to do that in a project, give some consideration to that practicality. And I'm not really trying to discourage you, just open up the idea of a critical dialogue about the application of these small turbines. There are applications of small turbines, though, that can be really efficient or important in other applications, so to speak. So here we have, this is in the Buffalo Medical Campus, and here we have light poles with both photovoltaic systems and actually in the center a vertical axis wind turbine. And they can be available to generate electricity for nighttime lighting systems. They can have onboard electrical systems to supply, or battery systems to supply all the needed power at night and be recharged. One of the unique things, or I guess one of the odd things about this, is that this should be totally freestanding. It shouldn't require any outside power sources, and yet there seems to be a wire running to it to supply it with something. Now it could be just the opposite way around. This is generating power and it's supplying it to something else. But one of the primary advantages of a system like this would be to not require this type of wiring to go between them. So um, there's something I noticed in that photograph. And then we have our classic horizontal axis wind turbine, a field array of them. We see this in the southern tier of Western New York all the time. And they have obviously some issues with them. And I'm bringing up negative issues because the positive issues are obviously obvious. You are generating energy from the wind. It's not creating a carbon footprint directly. So it's pretty much a win-win situation for the environment, at least on the face. But there are many places where these are being rejected. One of them is just because of this idea of visual pollution. The inundation of these in the landscape is objectionable, and that is whether it's valid or not is up for you to describe or decide, um, depending on your position on this. So it's also important to know that the wind energy itself, what you get off of a windmill, is really dependent on wind speed, and it's not a linear function. So we typically need, in order to site windmills, we need a place that is very windy. We come back to this issue of locations where um, Wind forces are being uniquely generated. Many times that's in areas that are well, clear of vegetation and elevated. So there's a change in pressure from air being heated, rushing up across the tops of these hills and creating high velocity at a level sufficient to drive the turbines in an efficient manner. So sighting and wind speed is really critical with these turbines. And they also have this requirement that they need to be spaced from each other. While this looks like a very dense um, array, it probably still has sufficient spacing because we're looking at it probably with a telephoto lens and everything seems like it's on top of each other. There's still this requirement of the idea of spacing of 3 to 5 diameters and to the left to the right, and then between the rows of arrays you need 5 to 9 times the diameter. And that's because each windmill is extracting energy, and there's these ideas of vortices and flows of air for the wind to recover downwind before another windmill can efficiently start to extract wind um, from the prevailing winds. Another objection that's found is this idea of them creating noise. You'll notice that the noise falls off rapidly as you move away from them. So this idea of, when I say far away from them, 300 meters is not a small distance, um, but it's in an urban area, but in a rural area that's relatively insignificant. But the idea of up next to them is like the sound of a lawnmower. 100 meters away, we're talking about something that sounds like a window air conditioner. And then we get to these ideas of acceptable levels at 400 meters away, where we've got the sound of a refrigerator. And once again, we've already learned from sound that the change between 90 and 105 is not insignificant. Um, and 40 dB is really quite quiet. So, but many objections come in communities because of the noise profile that comes off of the windmills, disturbing the built environment. So there's options of getting them away from the ground, the urban areas, and that's to put them out at sea or in waterways. And we still have people who are angry with the placement of these in the vistas of waterfront properties, but this is a consideration for placing windmills out in oceans and in waterways. I also invite you to understand basically how much energy is coming off of wind turbines when you're looking at siting them, looking at utilizing the power from them, how much you can actually power. Um, the output of a wind turbine depends on, once again, the size and the wind speed. Many times we have to be in air that's in the 10 mile an hour or better. Um, a large offshore wind turbine can generate this up to 3 megawatts of power. Power 1,500, in this case, European homes with electricity. But remember, that's not the full energy requirement of homes, and it's a small part when you consider the amount of fuel that's needed to heat homes. So you can also do these other calculations. You can take the kilowatt hours to convert it to gasoline, and then you can get an idea of, say we have 1 gallon of gasoline to commute to work, 200 days, and you can get an idea of how many cars would be removed from the road. And these calculators are relatively available or very easily available off the internet. You can just Google convert gallons of gas to kilowatt hours, or you can convert it to natural gas so that you can make a relationship between the electricity that comes off and other forms of heat that might be used for heating, etc. So next we'll pick up on hydro.